So I made this program. And then I modified the program to make it cooler. And then I made a video about that program, but I didn't record the audio. So am I recording the audio right now? I think that I am. But if I'm not, I'm going to be very kind of displeased about my audio recording abilities. So let's just do it. I'm just starting from scratch. I'm redoing the whole program. I'm gonna do the whole thing. So this is where we are. I made this Gauss's law problem, and this is a dipole inside of a box. And I calculated the electric flux by breaking the box into a whole bunch of little bitty squares and then calculating the flux through each square, assuming the electric field's constant in each square. I then painted each square red for positive flux, blue for negative flux, and the opacity of each square depends on the flux. So let me just go over this program really quickly because I already did this. Now I did make some change to this. One thing, there was a recommendation from someone on, I think it was on Twitter, very great recommendation. So by default, there's actually two lights, and this is something I'm never really good with, is camera movements and lights. But you can turn off the lights. Turn off the lights. I turned off the lights. So if I turn off the lights, then that's what this is right up here. There's two lights. There's a list of lights, and they're both set to visible equals false. Now down here, when I make each little bitty square, I put emissive equals true. So this means that each tiny square glows. Okay, so they're lights. Cool. Okay. So let's just go over this really quickly. The first thing I did was I'm trying to build these, I have these 6 sides, right? So, but each side has there's 2 pairs of sides. The first one is in the XY plane. So let me run the program, start from the scratch, make sure I'm oriented right. So this is the Y direction, and this is the X direction. The Z direction comes out of the page towards me. Okay, so XY area makes this area right there, and the one on the back side of the cube. So I give it a length of the area, width, a number of pieces, and the center of the area. Now there's probably a way I can make a function that's independent of XY. I could just say give it a unit vector, but I'm not smart enough to do that. Probably the best thing would be to kind of like build it and then rotate the whole thing, make a compound object. Yeah, I just realized that would be probably pretty easy. Well, whatever. I wonder if I could, okay, that's fine. Yeah, I didn't do that because I wanted still individual pieces in there, and I have to rotate all of those pieces too. So this just builds that area. Then I have one for the YZ plane. I have one for the XZ plane. This part right here, that just makes the 6 walls. I give them the dimensions and break it into 20 pieces each. That's that. And then I have 2 charges, a positive and a negative charge. And then I calculate the flux. This part right here is important. This is the average flux. Because when I calculate the flux down here, so I calculate the 2 R vectors for the vector from the point charge to the square that I'm interested in. And then I calculate the electric field. And then I use that to calculate the flux through that area. Now, in order to make the opacity right here, this is important. If it had 0 flux, I'd want it to be completely clear. So to do that, I have to kind of like scale the opacity, right? Because 0 means clear, 1 means opaque. And in order to kind of get it through there, I need some value of the flux. And this value of the flux depends on, if I break this into more pieces, then each piece is going to have a smaller flux. So I have to change that. And I don't have a way to do this manually. No, I don't have a way to do it automatically. I do have a way to do it manually, which is just go there and change this value. Okay, so if I change this to something higher, let's say 0.1, then everything should be darker, right? Because now the maximum, it actually kind of looks pretty cool. Look at that. And then if I change it to something lower, like 0, 0, 1, then everything's going to be brighter. See? So now they're almost fully opaque. So let's put that back at 4 right now. Okay. So then down here, what I do is I calculate the flux through each wall using those 2 charges. and then I print the fluxes. But what I want to do is move my dipole through the box. Okay, so let's do this. First thing I need to do is to go up here. Let's move these things. I want to put these both outside the box. So charge 1 is going to be, let's put it off axis a little bit. I'll put that at 0.2. And let's put this at negative 0.1. Negative 1.111. And let's put this one at negative 1 with the same y value. And let's just see what that looks like. Oh, and I'm going to save this because this is, I've modified this program a couple times and I don't know, I'm just getting confused. Oops. This is charge 2 is negative. I'll put that as 0. But that actually does look cool. Yeah. Okay. Okay, there you go. This looks good because you can see if I rotate this thing around that the box is barely visible. The box should barely be visible because the flux inside the box, the total flux is 0, right? These two charges are pretty close to each other. So there should be some, the positive charge is making, there should be some red over here, but that's weird. Okay, let's see. Let's separate these out a little bit. So put this 0.2, make them a little bit further apart. Okay, so the whole, I don't see any red. That seems to suggest I should see some red. Well, let's just leave it for now. Okay, the next thing I'm going to do is go down. I want to give them a velocity. So let's just let's just say an average velocity. Let's go down here. That's where I calculate the flux, right down here. What I want to do this is repeat this a whole bunch of times. So I'm going to say t equals 0, dt equals 0.01, v equals vector 0.500. Now I'm going to move the charges and repeat everything. So let's say this, while charge2.pos dot x is less than 1. Now I want to do everything in here indented. So the first thing I'm going to do is I should turn that off because I just realized that. Let's turn off this camera. The first thing I'm going to do is this, rate 100. This tells Python to don't do any more than 100 calculations per second. So since I'm doing a time step of 0.01, then this would be in real time. Okay. Now the next thing I'm going to do is calculate all the fluxes. So this is all the same. Tab, 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 tab. Okay. Next I am going to move the charges. So charge.pos. One's called charge and the other one's called charge2. Charge POS equals charge, spell it correctly, charge.pos plus v times dt, do the same thing for the other one. Charge2.pos equals charge2.pos plus v times dt, and then update time. I think, oh, that actually works, but I think that should work. I mean, all I'm doing is redoing the program, but I'm doing it a whole bunch of times, right? Okay, so let's run this and see what happens. Huh. Oh, you know what I did? Okay, I see. That's fine. I switched the order of the charges. I wanted the positive charge on the front. That's just what I did before. So let me just fix that. Okay, charge 2 is negative. Yeah, so let's put this one at 1. And this at negative 0.2. Now the positive's on the right. That's what I was imagining in my head. So you notice right there you get a negative flux because the electric field due to the positive one. See, right here it should be 0 flux, and it's not, right? That's not 0 flux. Why is that not 0 flux? Now that's back to 0 flux, or close to it. Why is that not 0 flux? Let me run that again. So there's your that looks good right there because I have a negative flux. Everything else is positive. It goes inside. I feel like I'm calculating the flux wrong due to the second charge. Is the second charge negative? Okay, let's go down here and look. KQR. Aha. Oh, QQ2. What's QQ2? You know what? They're not the same charge. What is QQ2? Do I even have a QQ2? Charge. Q. Oh no, that's inside the thing. Okay, that's fine. So when I call the flux, I call it as Q and negative Q. That's right. Okay, so Q2 is negative. That's inside there. So KQR. You know, I just realized there is a problem that I changed before and I didn't change it this time. I don't think nothing happened though. Last time what I did was I was worried about this R going to infinity to 0, and you're dividing by that. And there you go. I'm not squaring this one. I can't believe that. Okay, there you go. Oh, that is so much better. Wow, it's just, and there, that's perfect. I'm so excited. Okay, now I want to, and then, oh, look at that. Oh, yeah. Okay. Woo! That is so awesome. Let's make a graph. I want to plot the flux as a function of time, the total flux. So let's make a graph. T graph equals graph. Title equals total cube flux. I'm glad I redid this program because I didn't have a reason why my thing was wrong before. X title. No. X title equals time. Y title equals flux. In voltmeters. I think it's volt. Is that right? Voltmeters. Okay, then F1 equals G curve. Color equals color dot blue. I want to move the dots too. Well, this is fine. Okay. Now down here, I calculate the total flux. These are flux values. So actually, here the total flux is just the sum of all those things. So let's just copy this, put it right here, and then plot it. F1 dot plot T flux total. Spell it correctly. Okay, let's see what that looks like. Save it. Oops. Okay, let's rerun that because this goes from 0 flux before they get in the box, and then it goes to positive flux. Okay, excellent. This is, oh yes, this is exactly what should happen. Okay, and it was not happening before, and I was really kind of bummed about that. So here's the flux as it enters. That's very small. And then this is when that first charge enters the box, but the second charge is out. Now that both charges are inside the box, and it drops down to 0. Now the positive charge is going to leave the box, so that there's going to be a negative charge in there, and it'll have a negative flux. And then once the negative charge leaves, now it's again 0. Yes. This is awesome. I'm pretty happy. Okay, so there you go. I think I'm going to stop there. You know, you guys can play with this code if you want to. I'm going to give you the code. I'm going to give you the previous program. I'm going to give you everything that you need. It's going to be super awesome. But yeah, I'm pretty pumped about this.